What's up, math fans? Have you ever been in a pie eating contest? Well, if you were in a pie eating contest, you'd never win because it never ends. But an actual pie eating contest, you could probably win, and you could measure how much pie you ate. Well, when I have a circle, I'm thinking of it as either a pizza or some kind of cake or actual pie. So the outside or the outer part of the circle, the actual circumference of the circle, is my pie crust, okay? This is the circumference of the circle. Points on the circle are the circumference of the circle. So that's my pie crust, and you can measure that. Now, I have done videos where we talked about the measure of angles. So if you look at this notation, I ask you for the measure of arc. Arc is just part of the circle. An arc is like the pie crust. So if I want the measure of arc AB, well, that, if you look at this as a diameter, which it is because it goes through the center, AB is a diameter, then arc AB is like a semicircle, which measures 180 degrees. That's the measure in degrees. That's kind of like measuring the turn of the curve. But this lesson is arc length, not in degrees, but actual length, maybe feet or inches or centimeters or whatever the question is. So here, I would like to know the arc length. I'm no longer interested in the degrees. We mastered that already. So you might see different notation. For me, I'm gonna say either L for length of arc AB, like that, or you might not see an L at all, you might just see AB like that equals. And it does get confusing because you might mix this AB up with diameter AB, so it's probably more common for you to see length of arc AB like that. So my question is, what is the length from here to here? What if I wanted to know how much or how long that piece of crust really is if you straighten it out? Or if it's a pool, how much do I have to walk around half the pool? Something like that. I want to know the length. Length and angle measure is very, very different. So try not to mix that up. That's confusing, I know. And also the fact that this is spelled pie, and the pie that I refer to when I'm eating a pie is spelled pie, is also confusing. And it gets even more confusing when I get to number 3, where I talk about an even different kind of pie. So stick with me, all right? So let's get this out of the way. We're not talking about this. I want to know the length of arc AB. And all I know is that the radius is 5, okay? Let's pretend it's 5 feet. Doesn't matter. 5 feet. So how do I find length? Well, think about it. What do you know? You know circumference. You know that the circumference of any circle is the length all the way around, or the distance all the way around a circle. So the circumference is pi times diameter. Now let's do it in terms of pi, so I don't need a calculator just yet. That's going to be C equals pi times, I don't know what my diameter is, all I know is the radius is 5, but I do know that 2 times 5 is the diameter. So that's going to be 10 pi. I got my circumference, okay? How could I possibly find arc AB? Now it's just common sense, because since it's half of a circle, it's half of the circumference, which is 10 pi divided by 2, also known as 5 pi. Okay, that looks sloppy. I'm going to erase it. It's not even really helpful. How did I know to divide by 2? How did I know it was half? Oh, because it's a semicircle? Yeah. But what if it wasn't a semicircle? What if it was a little bit more or a little bit less? So I'm going to show you a formula. It's not even a formula. I like proportions. Geometry is a lot about proportions. So I'm going to set up a proportion. Let's see here. My favorite proportion is always part over whole. Part of a thing in comparison to the whole thing. So this time, I'm going to start with the degree measure. Here, I know this is 180 degrees. That's obvious when it's a semicircle. So that's part of the circle, and then the whole circle measures 360 degrees. This is what I said earlier about angle measure. That's old school, but I'm going to relate it to something new, length. So this part is related to this whole, and the length is part of the circle is related to the whole circle. What's the whole circle? Well, we just said the circumference was 10 pi because we know the circumference formula. So the whole circle is 10 pi. All right. Then you cross multiply and you solve. And guess what? You will get whatever I said earlier. What did I say? 5 pi. All right. Try it. I guarantee it works. I'm going to walk you through the next one. This was a circle before I erased it, of course. Okay, so I want again arc, length of arc, AB. How do I find it? Same formula, part over whole. So let's go. I know 60 degrees is my central angle, and I know the whole circle is 360 degrees. Let's see what that is. I don't know that. That's unknown, so that's my x. And what is the entire arc or the entire circle? That measures, I have no idea, it's not given, it's confusing. Well, they have to give you another piece of information here. So let's stick with the theme that all the radii are 5 in my examples. So let that be 5, let this one also be 5, okay? So I need to know the entire circumference, that's pi times diameter. So the diameter, even though it's bent, who cares? You still know that if the diameter was there, it would be 10. So that's 10 pi. Then you're going to go again to your calculator. You're going to cross multiply. And I'll actually walk you through this one, since I didn't do the last one. 60 times 10 pi equals 360x. I don't think you need the parentheses. It doesn't matter. So how do I get x alone? I divide by 360. Divide by 360. X equals whatever this is. So you go to your calculator. Let's see. 60 times. Now if the question says leave it in terms of pi, then leave it in terms of pi. But the question might say round to the nearest tenth or hundredth. So I'm going to do that. I'm going to round to the nearest tenth. So I'm going to do 60 times 10 times, and there's actually on the most calculators, there's actually a pi button. So don't say it's 3.14. It's actually a little more than that. So I'm going to do times pi, the actual button pi. Second up arrow gives me pi. Enter. So this on top is 1884.9555 blah blah blah. Divide by 360. And I get 5.235 blah 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 blah, which rounds to 5.2. Approximately 5.2. And keeping in the theme of feet, it's going to be feet. This one would have been 5 pi feet. Okay? Any questions on that? So this is in terms of pi. This is in terms of feet. Let's go. One more. What is this? Something new. Oh my goodness. Another pi. There's something called radians. And I'm not going to do a separate video on radians, but people did degrees for so long that they got bored and they invented something called radians. And it's just another way to measure an angle or a turn. And it turns out that pi radians is equal to 180 degrees. They made pi radians a half a turn. So 2 pi radians would be a full turn. So wherever I see something weird like this, I say, I don't like that, I'm used to degrees, I'm going to change it back to degrees by saying this thing really means 180 degrees. So pi over 6 is really equal to 180 over 6. What's that, 30? So that's really 30 degrees. Now I can use what I know from over there, part over whole. So I got 30 over 360 equals x over the whole circumference. What's the whole circumference? It's pi times diameter, right? Pi times diameter. Well, I know the radius is 5, the diameter is 10, so that's 10 pi again. And remember, the 5 can always change. It could be 6, then it would be 12 pi. It could be 10, then it would be 20 pi. Whatever it is, you just double it to get the diameter. Then I'm going to cross multiply. I'm going to get 360x equals 30 times 10 pi. And you're going to have to divide by 360 on both sides. I'm going to let you get a calculator, figure that one out on your own. Thanks for watching. See ya.